Our video tutorial is about quadratic equation. Let us differentiate linear and quadratic equation. The following equations are linear equations because the degree of the variable is equal to 1. Whereas the following equations are called quadratic equations because the degree of the variable is equal to 2. So these are linear equations and quadratic equations. A quadratic equation in one variable is a mathematical sentence of degree 2. So this is a quadratic equation. Ax squared is the quadratic term, bx is the linear term, c is the constant term, and this is the standard form of a quadratic equation, where a, b, and c are real numbers, and a should not be equal to 0, otherwise the equation is reduced to linear equation. For example, x squared minus 7x minus 8 equals 0. A is the coefficient of x squared, b is the coefficient of x, which is negative 7, c is the constant negative 8. Or this can be expressed in a factored form, these two quantities, x minus 8 times x plus 1. Another one, 2x times quantity x minus 4 equals 12. If we distribute 2x in each of the term, the same as 2x squared minus 8x equals 12. Or we can arrange the term in the equation so that it is in a standard form of the equation. We notice that 2 is common factor in each of the term of the equation. So we divide each term by 2 so that we have a reduced form of a quadratic equation, where a is equal to 1, b is negative 4, and c is negative 6. If b is equal to 0, then the equation is reduced to ax squared plus c equals 0. For example, 3x squared minus 1 equals 0, negative 5x squared plus 3 equals 0. If c is equal to 0, then this equation is reduced to ax squared plus bx equals 0. For example, negative 2x squared plus 5x equals 0, or 4x squared minus x equals 0. These are quadratic equations. Now let us illustrate some problems by a quadratic equation. Suppose your mother decided to construct a swimming pool in your backyard. She asked you to make a layout of a rectangular pool whose area is 28 square meters. She specified that the length of the pool must be 3 meters more than the width. Supposing this is the rectangular pool, and if we let W as the width and L as the length, and the area equal to 28 square meters, according to the problem, the length of the pool must be 3 meters more than the width. If we let x equal to the width, then we add 3 to the width, and that becomes the length of the swimming pool. Then from the formula of the rectangle, area is equal to length times width. If we substitute the length and the width, and the area is equal to 28 square meters, distribute x in each of the term, then we arrange the terms of the equation into standard form. Referring to the standard form of a quadratic equation, a is equal to 1, b is equal to 3, and c is equal to negative 28. Now let us solve quadratic equation by extracting square roots. For example, x squared equals 36. To solve for x, extract the square root on both sides of the equation. Square root of x squared is equal to x, and square root of 36 is positive or negative 6. So there are two values of x. One is positive 6 and the other is negative 6. To check our answer, substitute the value of x in the original equation. If x is equal to 6, then 6 squared is equal to 36. If x is equal to negative 6, and negative 6 squared is equal to 36. Another example, quantity x minus 3 squared minus 81 equals 0. Transfer negative 81 to the right, becomes positive, and extract the square root on both sides of the equation. Square root of x minus 3 squared is x minus 3, and square root of 81 is positive or negative 9. So we have two equations. x minus 3 equals positive 9 and x minus 3 equals negative 9. Solving for the equation, transfer negative 3 to the right becomes positive and combine. So one value of x is equal to 12 and the other value of x is equal to negative 6. To check our answer, substitute the value of x in the original equation. If x is 12, 12 minus 3 is 9, 9 square is 81, and 81 minus 81 is equal to 0. If x is negative 6, negative 6 and negative 3 is negative 9, and negative 9 square is 81, then minus 81 is equal to 0. Another example, x squared plus 9 equals 0. Transfer positive 9 to the right becomes negative. The equation has no real solutions or roots since there is no real number which gives us negative 9 when squared. Another example, 2x squared equals 50. Dividing both sides of the equation by 2 so that we have a reduced form of the equation. To solve for x, extract the square root on both sides of the equation. Square root of x squared is x and square root of 25 is positive or negative 5. So the two values of x, one is positive 5 and the other is negative 5. Let us solve quadratic equations by factoring. Example, x squared plus 7x equals negative 6. Transfer negative 6 to the left so that the right side becomes 0. So negative when transferred to the left becomes positive. And factor out the left side of the equation. The factor of x squared is x times x. The factor of positive 6, since the middle term is positive, the factor of positive 6 must be positive 6 and positive 1. So that if we multiply the terms 6 times x is 6x and x times 1 is x, and if we add, we got the middle terms positive 7x. After that, equate its factor to 0. So x plus 6 equals 0 and x plus 1 equals 0. Solving for x, transfer positive 6 to the right becomes negative, and on the other side, transfer positive 1 to the right becomes negative. So these are the two values of x, negative 6 and negative 1. Checking our answer, substitute the value of x in the original equation, x squared plus 7x equals negative 6. If x is negative 6, substitute x with negative 6. Negative 6 squared is 36. Positive 7 times negative 6 is negative 42. 36 minus 42 is negative 6. So they are equal on both sides. If x is negative 1, substitute in the original equation. So negative 1 is square plus 7 times negative 1 equals negative 6. Negative 1 is square is 1. 7 times negative 1 is negative 7. Combined, this is negative 6, equal to the right side of the equation. Another example, 4y squared plus 36 equals negative 24y. Arrange the equation in standard form. We notice that 4 is common factor in each of the term of the equation. We divide the whole equation by 4. So this is reduced to y squared. 4 is cancelled. 24 divided by 4 is 6. 36 divided by 4 is 9. So the equation is reduced to y squared plus 6y plus 9 equals 0. Factor the left side of the equation. Y squared is y times y. Positive 9 has factors. Since the middle term is positive, positive 9 must have a factor of positive 3 and positive 3. So that when we check the middle term, 3 times y equals 3y and y times 3 is 3y. Add, the sum is positive 6y. We got the middle term. Equate its factor equal to 0. So solving for y, transfer 3 to the right becomes negative. So one value of y is equal to negative 3, and on the other side, y is also negative 3. There is only one root of the equation. To check our answer, use the original equation and substitute y with negative 3. Negative 3 square is 9. Negative 24 times negative 3 is positive 72. 4 times 9 is equal to 36, plus 36 is equal to 72. They are equal. Another example, x squared plus 6x equals 16. Arrange the term into standard form of the equation. Factor out the left side of the equation. The factor of x squared is x times x, and the factor of negative 16 is positive 8 and negative 2. So that if we multiply 8 times x and x times negative 2, the sum is positive 6. We got the middle term. After that, equate its factor equal to 0. So x plus 8 equals 0, and the other factor x minus 2 equals 0. In this equation, solve for x, transfer positive 8 to the right becomes negative 8. On the other equation, transfer negative 2 to the right becomes positive. So the two values of x are negative 8 and positive 2. To check our answer, use the original equation, substitute x with negative 8. Negative 8 squared is 64. Positive 6 times negative 8 is negative 48. 64 minus 48 is equal to 16. If x is equal to 2, 2 squared is 4. 6 times 2 is 12. And the sum is 16 equals 16. Next, let us solve quadratic equations by completing the square. Example, 2x squared plus 12x minus 14 equals 0. This is the standard form of the quadratic equation. We have here the equation of a standard form of a quadratic equation. We divide the whole equation by a, the coefficient of x squared, then transfer the constant term to the right side of the equation. Positive becomes negative. So this is the step when we solve quadratic equations by completing the square. So let us apply this in our equation. The coefficient of x squared is 2, so multiply the whole equation by 1 over 2. So that this is reduced to x squared. 12 divided by 2 is 6. 14 divided by 2 is 7. Then we transfer out the constant term to the right side of the equation. So this is now our resulting equation. After that, add the same number to both sides of the equation. This number is taken from the coefficient of x, which is 6. Or the coefficient of x is divided by 2. So 1/2 of 6 is 3. After that, square out 3. 3 squared is 9. So 9 is what we are going to add on both sides of the equation. So the left side of the equation becomes a perfect square. Add 7 and 9 is 16. After that, extract the square root on both sides of the equation. Square root of x plus 3 squared is x plus 3. Square root of 16 is positive and negative 16. One equation is x plus 3 equals positive 4, and the other equation is x plus 3 equals negative 4. Solve for x on both equation. So x is equal to 4, transfer positive 3 becomes negative. So x is equal to 1. And on the other side, negative 3 becomes, positive 3 becomes negative 3. And combines, the other value of x is negative 7. To check our answer, use the original equation. If x is equal to 1, so 1 squared is 1. 12 times 1 is 12. 2 times 1 is 2. 2 plus 12 is 14. 14 minus 14 is equal to 0. If x is equal to negative 7. Negative 7 squared is 49. 12 times negative 7 is negative 84. 2 times 49 is 98. 98 minus 84 is 14. 14 minus 14 is 0. So they are equal. Another example, x squared minus 8x minus 9 equals 0. So transform the given equation into this form. Transfer negative 9 to the right becomes positive. Add on both sides of the equation with equal value. And that number is taken from the coefficient of x, which is 8. So 8 divided by 2, or 1/2 of 8 equals 4. Then square 4. 4 squared is 16. So 16 is what we are going to add on both sides of the equation. The left side of the equation is now a perfect square trinomial. and it is equal to quantity x minus 4 square. So the negative sign is taken from the negative sign of the middle term. X square is x square, 4 square is 16. 9 plus 16 is 25. After that, extract the square root of both sides of the equation. So square root of x minus 4 square is x minus 4, and square root of 25 is positive or negative 5. One equation is x minus 4 equals 5, and the other equation is x minus 4 equals negative 5. Solve the equation. Transfer negative 4 to the right, becomes positive, and one value of x is 9. The other value of x is negative 1. So checking our answer, substitute in the original equation. If x is 9, 9 square is 81. 8 times negative 8 times 9 is negative 72. Negative 72 and negative 9 is negative 81. 81 minus 81 is 0. And if x is equal to negative 1, negative 1 square is 1. Negative 8 times 1 is positive 8. 1 plus 8 is 9. 9 minus 9 is equal to 0. Next, let us solve quadratic equations by quadratic formula. From the standard form of a quadratic equation, we derive the quadratic formula. The derivation of quadratic formula is based on the method of completing the square. So this is the quadratic formula. So for example, let us solve this equation using quadratic formula. We arrange the equation into standard form of a quadratic equation. So transfer 27 to the left becomes negative. And our A is equal to 2, B is 3, and C is negative 27. Using the quadratic formula, substitute B with 3, B equal to 3, A equal to 2, C is negative 27, A is 2. Simplify. 3 square is 9, negative times negative is positive. 4 times 2, 8. 8 times 27 is 216. 2 times 2 is 4. Add the term inside the square root. So square root of 225 is equal to 15. So from this equation, we can have two values of x. One value is negative 3 plus 15 over 4. Simplify. Negative 3 and positive 15 is 12. 12 divided by 4 is 3. Another one, negative 3 and negative 15, negative 18 divided by 4 reduced to negative 9 over 2. So these are the two values of x, or two roots of the equations. Let us check the answer. Using the original equation, if x is equal to 3, 3 square is 9, 3 times 3 is 9, 2 times 9, 18, 18 plus 9 is 27. If x is equal to negative 9 over 2, negative 9 over 2 square is 81 over 4. Positive 3 times negative 9 is negative 27 over 2. Cancel out 4. That is 81 over 2. 81 minus 27 is 54. 54 divided by 2 is 27. So they are equal. Another example, x squared plus 5x equals 14. Arrange the equation into standard form of a quadratic equation so that we can identify A as equal to 1, B is 5, C is negative 14. Using the quadratic formula, substitute B with 5, A with 1, C with negative 14, and A with 1. Simplify first the operation inside the radical symbol. 5 squared, 25, negative times negative, positive, 4 times 1 times 14 is 56. 25 and 56 is 81. Square root of 81 is positive or negative 9. Then one value of x is negative 5 plus 9 over 2, and the other value of x is negative 5 minus 9 over 2. Simplify. Negative 5 and positive 9 is 4. 4 divided by 2 is 2. Negative 5 and negative 9 is negative 14. Divided by 2 is negative 7. So these are two values or the roots of the equation. Checking our answer, substitute the value of x in the original equation. If x is 2, 2 square is 4, 5 times 2 is 10. Then combine, they are equal. If x is negative 7, the square is 49. This is negative 35. 49 minus 35 is 14. They are equal on both sides. So that's enough.